Welcome to this explainer. Okay, so we are diving straight into an absolutely incredible scientific mystery today. To set the scene, I want you to imagine diving deep, deep into the ocean off the coast of Sicily. If you swam far enough down, you'd suddenly find yourself surrounded by a massive, silent forest of strange technology. Honestly, it looks like a scene pulled straight out of a science fiction movie, but it's entirely real, and it's operating right now. Picture this. Scientists are taking over 900 mysterious glass spheres, hooking them up on a massive string, winding them into an even bigger ball, and dropping them straight into the Mediterranean Sea. Once they hit the ocean floor, they unroll to nearly twice the height of the Empire State Building. And they do this again and again. But the craziest part? Up on the surface, hidden inside an abandoned winery that's been turned into a high-tech lab, a computer is just watching these spheres and waiting.
They were waiting for something highly specific. And in 2023, they finally saw it. Something way smaller than an electron tore through this underwater forest at nearly the speed of light. It set off a signal nearly 30 times more powerful than anything we'd ever seen like it before. Naturally, you'd think this meant something astronomically huge just happened out in deep space, right? So telescopes all around the world immediately swung in that direction to see what it was. And the crazy part? They found absolutely nothing.
Section 1. Meet the ghost particle, the most elusive target in physics.
Okay, let's dive into this. Meet our prime suspect, the neutrino. To catch this elusive target, scientists built that massive underwater forest, which is called KM3net, along with another huge global effort buried deep in the Antarctic ice called IceCube. To understand why this particle is so notoriously hard to catch, we kind of have to change our perspective. Imagine you and I jump into a spaceship and fly to the closest star. It's nearly 40 trillion kilometers away, so that flight would take us about 75,000 years, mostly because there is just a massive amount of empty space in space. Well, if we shrink down to the perspective of a neutrino, the space between the nucleus of atoms in solid matter is proportionally just as huge. A neutrino can zoom right through the atoms of solid rock just as effortlessly as our spaceship flying through the empty vacuum of space. It's honestly hard to wrap your head around just how close to nothing these particles actually are. The scale is truly mind-bending. If you took a single neutrino and scaled it up so it was just 1 millimeter in size, a human being, proportionally scaled up, would be the size of an entire galaxy. Because they're so incredibly tiny, they pass through basically everything: stars, planets, walls, and yes, even you. And that is exactly why scientists nicknamed it the ghost particle. Actually, do me a favor real quick. Just hold up your thumb. Take a look at it for a second. Right at this very moment, 100 trillion neutrinos are passing through your body and right through that thumb every single second. They are constantly raining down from the cosmos, and you don't feel a thing.
Section 2. X-ray vision for space. Why traditional telescopes are blind.
So you might be wondering, if neutrinos just pass right through everything, why do we even care? Well, it turns out this exact fly-through-walls superpower is actually the ultimate key to unlocking the universe's biggest secrets. Up until now, astronomy has basically relied on 3 main options to study deep space. Option 1 is light, covering everything from visible photons to radio waves and gamma rays. Option 2 is cosmic rays, which are these high-energy charged particles. And option 3 is gravitational waves, which are literal ripples in space-time itself. But here is the glaring problem with all 3 of those methods. Vital cosmic evidence is constantly being destroyed or scrambled before it ever reaches Earth. Light gets blocked, reflected, or delayed by dense matter and space dust. Cosmic rays have an electric charge, meaning they get tossed around and warped by magnetic fields, so we literally can't trace them back to where they came from. And gravitational waves? Well, they tell us a massive event happened, but they don't tell us what it actually did or what it's made of. The evidence simply takes a wrong turn. And that is why the neutrino is so deeply special. It's our new 4th option. Because of their incomprehensibly small size, they're incredibly unlikely to get blocked by anything. And more importantly, they have 0 electric charge, so they don't get warped by magnetic fields. They travel in a perfectly straight line at almost the speed of light directly from the source to us. They are literally the perfect, untainted cosmic messenger. If you can trace a neutrino, you can see right inside the most violent events in the cosmos. Think of it like a doctor giving you an exam. Visible light lets them see your skin. But if they need to see your bones, they use X-rays, because X-rays pass right through ordinary tissue.
Catching neutrinos is like developing X-ray vision for the entire universe. We can use them to look straight into the core of a collapsing supernova, the cosmic engines that forge the very elements making up our planets, including the iron in your blood. Section 3. How to catch a ghost. Building a trop 3,500 meters underwater. So here's the ultimate engineering paradox. How on earth do you build a machine to catch a particle that statistically refuses to interact with anything? The answer? You build a very, very big, and frankly, very crazy machine deep underwater. The core of this machine is called a DOM, or Digital Optical Module, and they are painstakingly built by hand in a lab in Caserta, Italy. They start with a thick glass hemisphere and an aluminum base. Inside, they place a mini computer brain and 31 photomultiplier eyes. But here's the really wild part. We don't actually have the technology to see a neutrino directly. So despite hunting for ghost particles, these delicate deep-sea DOMs are really just looking for faint flashes of light. Now, what's really interesting about this is the sheer absurd level of sensitivity these eyes possess. Each one can detect a single photon of light in the pitch-black deep ocean. To put that into perspective, that is like standing in the middle of a screaming, massive hurricane and being able to clearly hear a single drop of water hitting a leaf. And they absolutely need that hurricane-level sensitivity to witness the end of an epic journey. Imagine a neutrino born in a massive supernova. It escapes the star's dense core and travels for 1 billion years in a perfectly straight line. It reaches our pale blue dot, totally uncaring that Earth is even here. But, just by sheer random statistical chance, one out of those trillions of neutrinos accidentally crashes headfirst into a single proton inside a water molecule off the coast of Sicily. That crash creates a heavier particle that flies through the water faster than light can travel in water. The result is an underwater sonic boom, a microscopic glowing cone of blue light. And that single unimaginably faint flash is exactly what the machine is waiting to see. But how do they separate that rare blue flash from all the other glowing deep-sea noise, like bioluminescence or cosmic rays raining down from the sky? Well, they do it by looking down. The sensors are pointed toward the ocean floor. They actually use the entire rock of planet Earth as a giant filter, because only a ghost particle like a neutrino can travel all the way through the Earth from the other side and burst up into the ocean water. So in this setup, the entire planet is literally the lens of the telescope. Section 4. A new era of astronomy. Solving the universe's biggest cases. This wild cubic kilometer engineering feat, combining CAM3 in the water and IceCube down in the ice, isn't just some fun science experiment. It's already fundamentally changing our understanding of the cosmos, kicking off what scientists are calling a brand new era of astronomy. Just look at how fast things are moving. In 2017, IceCube caught a high-energy neutrino, traced it perfectly straight back, and found a blazar 4 billion light-years away, which finally confirmed the source of cosmic rays. Then, in 2022, they used neutrinos to peer inside the hidden dust-choked core of an active galaxy 50 million light-years away, something normal light could never show us. And of course, in 2023, CAM3 detected that massive, unprecedented, and still totally unexplained signal. Like one scientist perfectly put it, this is a watershed moment. For the first time in human history, we have all 4 methods of observation working together. We can watch a cosmic engine with photons, measure its gravity waves, catch its cosmic rays, and now we have the X-ray vision of neutrinos to look deep inside its core. But amidst all this grand cosmic scale, there's a beautifully grounding human element to this story. These massive scientific instruments are being built by hand, piece by everyday people. One of the builders in Italy noted with a smile that he used to be a factory worker, and now he is building the eyes that will unravel the universe's secrets. It's just a profound reminder of human ingenuity and the immense pride we take in building tools that push the boundaries of what we can know. And that brings us to the end of our explainer today. I want to leave you with one final thought. These incredible machines sitting at the bottom of the ocean and buried in the Antarctic ice are ultimately just extensions of ourselves. They are our new eyes and ears, taking us to places we could never physically go. With that massive unexplained signal from 2023 still echoing in the data, it leaves us with a thrilling question. What other invisible, earth-shattering secrets is the universe hiding, just waiting for our new cosmic eyes to uncover? Thank you so much for joining us, and stay curious.